Hello everyone, I am Yshay. Today I'm going to talk about ephemeral environment, more specifically ephemeral environment as part of a pull request flow, Privy environment. Actually, I was about to give this talk yesterday, but I had a flight disruption, so it ended up being today. So before we begin, I want to tell you a bit about my first experience with ephemeral environment. It was back in 2018. My team was working on a new product. Our company has been using microservices for quite some time, and we had well-established CI/CD pipelines. But the thing is, we wanted a different pipeline. And to understand that, I'm going to talk a bit about our original deployment pipeline. So we had a feature branch with an open pull request. We ran unit, black box test, merge to main, deploy to a canary cluster, run sanity test, and eventually deploy to production. But the thing is, all these steps were manual. And it was a very manual process. Deployment could spend to over an hour. It required a lot of attention from the developers. And it created bottlenecks on the main branch, which for me, it was something that was really disturbing. So we rethought our deployment pipeline. We wanted less manual steps. We wanted no blocking of the main branch. And we basically wanted to be continuous deployment as much as possible. And that was the architecture we came with. So developer commit to a feature branch. Automatically, there's ephemeral environment that is going to be created or updated. And once we merge the branch to the main branch, we deploy automatically to production, to the cloud. So we added this ephemeral environment. We created a process that build and deploy every branch revision. Each revision was accessible with a public URL. It was available during the entire PR lifecycle, and it was used for testing and automation. We saw early sign of success, faster feature deployment and release, no more bottlenecks on the main branch, and in general, more confidence in our feature quality. But there was more. These ephemeral environments were actually a game changer for us. We started testing these features in different devices in isolation, basically everywhere, because we had these public URLs available for everyone. It was used for showcasing new features. We can debug features that already that are not yet in production, but we can try them. It was used for communicating the product status. And most importantly, these environments were used by the entire team, not just developers. Product managers, designers, everyone was using them. And as a result, the developers were also more happy, more productive, and suffer less from context switches because less meeting and less demos. And developers are bottlenecks in many cases. So it was pretty success. A few words about myself. I'm Yshay. I'm a CTO and co-founder of Lifecycle. I'm a former tech lead and a staff engineer. I have 15 years of experience with software development. I worked in the past on several open source projects. I'm passionate about cloud development, functional programming, lots of stuff. And basically, I love using Docker and Kubernetes. They were my go-to tools in the past 7 or 8 years. A few words about Lifecycle. So it was founded 2 years ago. We are building the next generation of collaboration tools for product team. We're embedding rich collaboration tools on top of ephemeral environment. And we try to bridge the gap between developers, designers, product managers, and other stakeholders. So on the agenda today, I'm going to talk about ephemeral environment, about our open source tool called Privy that designed to enable provisioning ephemeral environment to use this process. And I'm going to break down the components of ephemeral environments. So what are ephemeral environments? As the name implies, ephemeral, lasting for a very short time. It's a working application that represents a state of the code base and the configuration. It's usually accessible by public URLs or at least dedicated HTTPS URLs. It's also known as PR environment, preview environment, review apps. You probably heard it in other LESs, other terms. So why do we need these environments? They can use for lots of cases like demos, manual QA, code review, product design review, testing, collaboration. And the thing about ephemeral environment that they can bring other stakeholders to the development process. So I'll show a quick example of how we use the ephemeral environment lifecycle. So we have an application. You probably know this one. It's a Wordle app. And let's say I added a new feature called int, that I can have an int that give me away the secret of, that allow me to know what, an int for the riddle of the day, sorry. And I added this feature as a developer, but now I want to share it with the team, and I want to get some feedback. And we added this layer of tools on top of the environment, so the ephemeral environment lies in the center, but in the side we have several tools for leaving feedback. We have a screenshot tool, a video recording tool, copy, CSS suggestions, and I can leave this feedback. And it's going to be integrated to the pull request for this feature. So I have this feature, add dictionary int, which take this int from a live dictionary, from online dictionary. And we can see the message I've entered here, and developers can see it and communicate better with with their peers. So that's the experience we bring in with Lifecycle, and because it comes from this idea that preview environment can change the way we develop software. And things that we saw that once teams embrace and adopt ephemeral environment, there's usually no turning back. They can't go back to the point that things are slow, that they need to have this process for looking at this code. For example, I'm doing a code review. I'm cloning the repository on my computer. I'm building, deploying, I'm stashing the change of what I'm working currently, only to see how does the application behave. And once I can experience that with a click of a button for every code revision, it's usually difficult to go back. And that's for developers. For the other stakeholders, usually they need to wait for the feature to get to staging or to production. So we saw that once teams started to use them, even on particular service, it got advocated across the organization, and they tried to use it for other projects as well. And we built this platform to make the most of ephemeral environment, but we have a problem. Most development teams haven't implemented a ephemeral environment. And that wouldn't be a problem unless it was not that trivial to implement. It requires expertise and knowledge in different disciplines, from application development to DevOps to platform engineering to some degree. We need to strike the right balance between fidelity and cost to have effective ephemeral environment, and we need to combine multiple different technologies and tools to make it work. Also, something we discovered at Lifecycle is that the ownership on ephemeral environment is usually there's not a clear owner. It can be like DevOps, platform team, app developers, and in some cases something else entirely. So for that, we've developed Privy. It's an open source solution for provisioning ephemeral environment. We released it a few months ago. It got some traction. It's designed to integrate easily with existing CI/CD pipelines. It's built on top of Docker and Compose. It supports local experience, it's flexible and extensible, and we designed to be simple as possible. We actually learned quite a lot because before that, we created our own hosted solution for provisioning preview environment, and we had like this streamlined approach that you do it with our format, and we are connecting to GitHub repository, and we are doing everything. And we saw that users need this kind of flexibility. We need something that will be more easy to integrate and easy to try, and something that can work for more complex application. So that's why we developed Privy. It's an open source solution. I'm going to show a quick demo. So I have this application that actually Docker created. It's a multi-service application, not necessarily a full stack one. So it has two front-end applications, one back-end worker, two databases. It's called cats versus dogs. And here I have the Docker Compose definition of the application. So we can see we have one service for voting, the other one is for result, the worker, and the thing about it is that all the definition that is needed for the application to run is in a single YAML file. It's not as complex as we see usually with Kubernetes and other tools. So here I have a demo recording of Privy running. I can show it afterwards in like a real terminal, but I just had some problems with it before. So I'm going to create a new context, in this case a Kubernetes cluster context for setting the infrastructure for my Privy environment. And then after I created this context, I'm just going to use the command app. And behind the scene, it's going to provision the resource needed for the Privy environment. It's going to build and deploy the application. And lastly, it's going to create these URLs that I can access the application and use it. So here I have the application running. This is actually iframe, so it's a real application that's running. We have two URLs that I got from the Privy app command. One is for the front end of the voting, the other is for the result. And let's say I want that's a screenshot. Yeah, and now let's say I'm going to switch a branch. I'm going to work on a feature. So I'm going to do a git checkout just to show the pause here. Okay, so here I have the diff, which is basically, So it's basically I added the data seeding, I changed the label of cats versus dogs, I changed it to robots and wrestlers, a bit of a UI thing, and that's all. And now I'm running a Privy app again. And I'm going to get another environment that is going to be built. And I'm going to get, again, two URLs. And if I use the command Privy ls, I also will see the two environments that are running side by side. So here is another application. Notice that the URL contains the name of the branch. I don't know if you can see it from here. But it called replace subject. And I also have lots more votes because I integrated data seeding here. So there was a container that ran that just fill out the data in the application. So that's the idea of Privy environment, having an environment for every branch. So the Privy environment, when we designed Privy, we thought about what are the properties we want our Privy environment to have. So we want them to be cheap. We wanted them to be cheap in terms of like the cost of maintenance, configuration, bootstrap, and of course hardware. We want them to be integrated, to be part of a CI/CD pipeline, that it will be easy to integrate it with other tools the team is using. We want it to be customizable, so I can add data seeding or another container for debugging the application, or doing code editing, or whatever. We want it to be debuggable, so the idea that we have a preview environment if we tackle a problem during the development process, so we can take all these logs and monitoring and put it as part of the feedback we are giving the developer that created the PR. And we want it to be accessible. That's why we have like public URLs that you can use for accessing the applications. We also thought about fidelity quite a lot. How this environment mimic production environment, how close this environment should be, and think about using real data again, or data seeding, and of course we can talk about security compliance. And when we thought about it, we saw that, and when we talked with other companies, we saw that when we establish a preview environment, it can be from the direction of we're taking our development environment and enrich it and make it, we make the fidelity there higher and we have a preview environment, or we can do it for the other way around. We can take a production environment and lower the fidelity there to have an ephemeral environment. And the reason we need to do it is because production environment comes with a huge cost. We need to take care of high availability, of scaling, different kind of observability, security, compliance, and all this stuff is quite counterproductive to our environment being cheap and accessible and debuggable and all the other properties we wanted to set. So we can talk about production and development. They have like different properties. And these properties are not just in ephemeral environment, they are also in testing. For example, we don't create lots of E2E tests in the famous pyramid of tests because they are expensive and because they are slow and they are complex. So we create many unit tests or integration tests, but that's the thing. We can create our ephemeral environment that they will be useful to our PR flow, and that we can create many of them, and not necessarily to replace our staging environment. So I go a bit about the building blocks of building the ephemeral environment. So first of all, we have the infrastructure. How do we provision the resources for each environment? How do we tear down the resources when we are done? How do we integrate cloud credentials and cost? There are various tools to accomplish that. Infrastructure as code usually, Pulumi, for example, or CloudFormation. At Privy, we chose to implement abstraction for a machine provider. We implemented one for each of the major public cloud vendors. We also implemented a provisioner for Kubernetes. We also support custom deployment pipelines. And the idea is that the Privy CLI can, in a single command, create a machine. It could be on Google or Azure or AWS, and it could be on Kubernetes. You simply configure the context for Privy CLI, and it's going to use that kind of infrastructure. The next thing is a platform. So how do we run our application? How do we orchestrate, isolate? We can talk about Kubernetes, serverless, control plane, PaaS. Privy, we chose to, first of all, base it on containers, as you saw before. We are using Docker toolchain, and specifically, we are using Compose. I think the main benefit of using containers is that they are very generic and very popular. It's easy to run many sorts of applications and run them in different environments. They're also popular and well-known, and they are flexible. We can attach easily volume to them, or storage, or change the properties. Quite nice. And specifically, we chose to go with Docker and Compose because I think Docker did an amazing job of bringing containers to the masses. So Docker Compose is something that developers can grasp if they're using containers. Kubernetes, on the other hand, or it's never just Kubernetes. It will be with Elm or Customize or another tool are much more complex, and there are many cases that we want to create an environment that will be simple and cheap, and we want to run it fast, and that developers can modify it if they want to change something, and not create another Helm chart or change something there. Application. How do we build our application? How do we package it? How do we configure dependencies? Basically, because we are using Docker, we have the solution here. We are using Docker file and compose file. Specifically, Privy also synchronize mount volumes to provide better compatibility to compose. So if I'm running Docker compose and I have mounted volumes, they are going to be copied to the remote machine. And compose it's really amazing. I mean, besides defining the containers that we want to build, it allows us to build a pipeline of build, push, and deploy. It can work without a registry. We can control the service startup order in a very easy way. It supports variable substitution out of the box. We can merge and overlay multiple files, and it can build from external context. So to showcase this example, I created another compose definition for Preview environment. This time I created a Preview environment for Privy itself. So I'm building Privy from a fork I created, and I created a dedicated branch. So you can see that in the service definition here, I'm not specifying my folder, I'm specifying a Git context. So for example, I could create a Docker compose composed of several microservices that are in different repositories. And it just work. Because Privy is a CLI, I created another service that I can use Privy because it's a terminal application. So that's the Preview environment for Privy. We can see the URL here, and basically I have a terminal here that have Docker compose and have Privy itself. And I even created a command for the stock, so Privy navigate. So yeah, and that's an example that we use Privy environment for a different kind of application. It doesn't have to be like a web UI. It can be even a CLI. I'm going to talk a bit about access because that part is very tricky. So how do we expose the environment? How do we manage routing? How we deal with TLS termination? And how do we secure access to the environment? So there are lots of stuff that we can accomplish if we want a secure environment. It can be a configuration of OAuth, maybe VPN in some cases, also DNS, and we need a reverse proxy for that. Privy basically supports lots of features in this area. It creates friendly URL based on Git context. It supports private environments and services that can be based on private key authentication or external identity authentication, like Google Identity. It has tunneling-based solution for passing the network, so it can work locally, on-prem, and cloud, everywhere, a bit like if you think about ngrok or similar tools. We implement this access layer with an open source tunnel server that we've developed. It's also part of Privy project. It supports SSH-based tunneling. It does the TLS termination. There's a publicly available instance on lifecycle.run, so that's why the URLs also add lifecycle.run. It can be self-hosted. And there's a support for JWT integration. Lastly, automation. We want to have a workflow that automates the creation of this environment. There are tools for doing that, like Argo CD or GitOps, if we think about technologies. At Privy, it's a CLI that can be used locally and the CI/CD pipeline. We have cloud profile for sharing the state of the environment. So if I'll do Privy LS in my computer and in the cloud CI/CD provider or Privy down, it will remove the right instance. We have a plugin system to support external automation. So here I have example of the GitHub external link that put a comment in the PR with all the links to the environments. And we also have the dedicated action for GitHub Action and Circle CI. So that's basically it. I'm going to summarize. I truly believe that the Fermyon environment can bridge gaps. There are not just technical gaps, but also like organizational gaps. It can bridge the gap between developers and non-developers, and it can make like we have a coder vision that will always be corresponding to a live environment. So that's like a very strong capability that can improve our feedback loop tremendously. Privy designed to make it easy and cheap. We are playing many features for the future of Privy, so it will be interesting. And I suggest you try it. It takes a few minutes to run, and you can have Privy environment as quickly as possible. Thank you very much. Thank you. Yeah, sure.
So I understood, for example, if I deploy on the Kubernetes, okay?
Yeah.
I understood now I still have to maintain a Docker Compose file. So I have a little discrepancy for when my ops team or I go to another stage.
Yeah.
So is this intentional? What is your opinion on this, that I have two different formats which maybe then tested with Privy, yeah, it works, and then the ops team says, yeah, it doesn't work because...
Yeah, it's a great question. To be honest, currently it's intentional because we wanted to lower the gap of entry and to provide this ease of customization. For example, like in the CLI example, I'm just adding a container, and Kubernetes itself, usually the pipeline is more complex. In addition, in many cases, it's not just on a single repository. You have a dedicated GitHub repository, and you do a pull request to that repository. So the idea is that to mimic something that is more similar to a development environment. Now, if your development environment is also running Kubernetes, so currently we don't have like the best experience for running the Kubernetes app in Privy. I believe at some point we'll support it because we see that Kubernetes is used also for a development environment locally. But I do think that in many cases that the teams are using it, they are not getting the best development experience because it can be like slow and complex and break, and usually they don't know how to debug it if they have a problem. And that's the reason we want something that will be more easy, because Kubernetes also brings with it all the complexities that are more ops related and not dev related.
I saw recently the work from Zero D, and I saw the people from Zero D say, okay, you can have your Kubernetes environment but still debug locally and so on. So that's the thing.
Yeah.
Right, it doesn't help with the collaboration, right? If we use Netlify, we also Preview environments. Like a big part of the value is that I can share it with our designer who doesn't have it.
Yes, you can share the link. Yeah, that's a good part. Yes, of course, that you can deploy it. So
Yshay, I got around 5.
Thank you.